Hello everyone, my name is Biddlecom. I am the motion product specialist here at EandM, and today, in similar trend to previous videos I have made showcasing various configuration tools in both the Siemens and Festo portfolios, I'm going to be following that trend and showcasing Festo's handling guide online or HGO configuration tool. Similar to the electric motion sizing or EMS configurator shown before, this tool helps to easily document, size, and bundle all in one place a multi-axis gantry system, making it easier and faster in sizing multi-axis motion projects you may have currently. Okay, now that introductions are out of the way, let's get started with our handling guide online configuration. So here we start just like before on previous Festo videos. We start on the Festo website, logged into my Festo, and from here, similar to the EMS configuration, we go to Engineering Tools. Bring us to this page, but instead of going to EMS, we're going to go right underneath to Handling Guide Online. Little introduction for the Handling Guide Online, just click Accept, and from here is our first choice of what sort of application or solution are we looking to size today. We can go single, 2D or 3D axis gantry systems, whether it be a linear gantry or some sort of 2D or 3D cantilever system, as can be seen below. For today's video, I'm going to be doing a 3D gantry system, meaning we have 3 axes of movement in the X, Y, and Z. So we have X, Y, the spindle moving back and forth, and a Z moving up and down, like a pick in place, so to speak. So to begin, we just click on 3D gantry, just make sure we select that, and then we just hit continue. We go to our next step, which is definition or defining of our axes and our payload. So what's really nice about the 3D gantry system is we can choose between either electric servo or stepper solution, or we can go to a pneumatic position. So 2-position pneumatic, very common for pick and place applications. Just for today, I'm just going to do a little mix and match. I usually don't cover the pneumatic side much, but it's just a really cool part of the HGO. I just kind of want to show up to see how we can blend all of Festo's portfolio together into one solution. So selecting pneumatics for our Z-axis here. Next, we have our stroke length. So similar to EMS, what stroke length, what distance are we going in our configuration? I'm going to do 1000 millimeters in the X, 500 in the Y, and in the Z, we're going to do a 100 millimeter stroke. After we have our stroke lengths and stroke distances defined, we're going to go to our payload, and I'm just going to put a 20 kilogram payload there. And then here we have something new from what we had, actually not too new. We never really defined it before in EMS, but we do have our distance from the center of load or center of gravity. So here we have our gripper or our front unit of the device, the payload we are picking up highlighted in blue, and then between the two here is where the center of gravity of this example piece in this diagram would be. And from here we'd have our X, Y, or X, Y, and Z format of what is the offset of this center of load. So since we kind of left it at 0 in our EMS video from before, I'm going to define this now with just a 10 millimeters in the X, 5 in our Y, and let's just say another 10 in our Z, just to see how that can affect some measurements, or just telling the system, hey, we do have a non-uniform payload structure we're picking up, so just be aware of that. But from here, we can now continue to a third step by clicking continue at the bottom. Next, we're now going to be defining truly in our full stroke length what our actual travel distance is. Usually this is going to be the same as what we defined previously, but let's say you had like 1000 millimeter stroke length, but really that you wanted to choose and define, but really you only needed to travel like 800 millimeters conservatively. You could put that here. However, for this, I'm just going to match what I put in before. So 1000 millimeters, 500 for the Y, and then our Z is broken up into 2 paths or 2 options. Since it is only 2 positions, it autofills 100 millimeters. So essentially it's going down 100 millimeters and then going back up 100 millimeters. So we can't really edit these here because of this two-step system with our pneumatic cylinder. If this was an electric servo, we would be able to define the full stroke length similar to our X and Y. Moving on from that, then we can then choose between our motion profile, which can be either a blended path, which interpolates motion between the X, Y, and Z axes to have a, as the name suggests, a blended path of axis or a blended path of motion from point A to point B. Or in this case, I'm going to change it to Z axis sequential, so our X and Y will move, and then our Z come to standstill, and then our Z will move up and down its required stroke length for the project. If you ever need more information about any of these options as well, similar to what we've done in previous videos, Festo gives us these info buttons, and so simply by clicking on them, we can get a little bit more information about what the difference between blended path and Z-axis sequential can be. So here you see that curve of interpolated movement for a smoother motion profile, and then Z-axis sequential is very much, boom, more blocky. So in this case, full Z, full X, full Y, full Z type situation. From here, we then have our cycle time. So let's say I'm going to be a little conservative here. Let's say I want our travel time to be 10 seconds between point A and point B, and then the gripping and waiting time between moving from then like point B to point C or back to point A, let's just give that 5 seconds, giving it a lot of time for setting, gripping the payload, and getting ready to move to the next location. Of course, then our cycle time is the combination of both travel and gripping / waiting time, so we get to a total of 15 seconds. Below, we also saw this in EMS in the motion profile, but any additional forces in the Z direction. So in this case, in the point 1 and the point 2 of our Z-axis, this is defined at like Z1 and Z2 above. So this is just saying if you have any positive or negative forces acting either with or against the movement of the, besides the payload, of the workpiece with the payload in hand, whether let's say like it's pulling it off of some sort of press fit fixture that the payload is at the bottom and might have to overcome some force from there. So that would be a negative force that's going with it, for example. For now, today though, we're just going to be like, we're just picking this off of conveyor or just off of a table. So I'm just going to put 0 for both. And then of course below, we can choose between the many options that Festo offers in both its electric and or AC and DC stepper alternatives for their electric servo applications, or electric servo solutions, I should say. So I'm just going to go a very common 480 volt 3-phase option and then choose not available for both the single phase AC and the DC stepper voltage options here, just so I can narrow my options down to the 480 volt. Click continue. And so now after this, it's going to take a little bit of time to think to get the results of the calculations we put in. So here we have a system series, YXCR-3 that's been defined. The system workload or total workload of the products in this gantry system are at 44%, so that's underneath halfway. So this system isn't really pushing its boundaries too much, so the products will not experience wear or tear faster over their service life. Our repetition of accuracy is shown here. It's a plus or minus 0.11 millimeters, and then no price shown at the moment. Down below, then we have a breakout of what our 3D gantry option here is giving. So our X and Y axis are both EGC 120 actuators at the following stroke lengths. They do have a gear unit, it seems on here, a 5-to-1. Here are the motors we are having down here with their servo drives connected, and nominal voltage 3-phase. And then of course we do have a change here where we have in our Z module, we do have this pneumatic mini slide DG-SL-25 with other options here and a breakdown of the workloads below. As you can see, the workloads are very, very small, with the most being in our Y-axis at the 44%, shown above in our options. If there are more options that better fit, or more options that were fitting for this solution, we would have them listed here, and simply by selecting this check mark, we would see the change in the 3D gantries below, in our 3D gantry options below for each of the axes products being used. So from here, we're just going to continue, and we're going to further configure our system now in terms of the motors, servo drives, and sensor packages, as we will be seeing. So we're going to start up here at the motor attachment position. So for our Y, we are kind of set, as well as our energy chain as well. That's the blue energy chain right there with all the cables in between on this axis. We're kind of restricted to the left, but if we wanted on our x-axis, which is this motor here, we could just simply switch that to the right, just kind of choosing where we want the motor mounted on our x-axis. I'm going to leave it at the left for now. Just wanted to show that. And then below, we're going to have our Festo motor and drive. So by clicking Festo motor, we can further configure it here, showing whether or not we want a motor brake for either of our axes. In this case, no. We're just going to keep it simple. No brake on there. Keeping our encoder type to an absolute multi-turn. Always like going that route. And then moving down from our motor, we have our Festo drive. Here we choose our field bus interface. Any of the Ethernet protocols, I'm going to go to Profinet. As we know, we like to mix things here with our other vendor, Siemens. So Profinet is our main communication with them. We have our motor controllers for each of our axes. So with the Z is without, because that is pneumatic, but we do have our CMMT-AS servo drive for our X and Y axis. It comes with basic STO. And here we can select if we want a braking resistor and an operating panel with touchscreen. I'm just going to click yes on that. But if we want more information, I hit info, and just shows this little operating panel with touchscreen that we can have for the servo drive. Click OK when you're done. And then down below, we have our Festo sensor package. Just to show the options here, I'm just going to click to select that. And then here we have our different bipolar junction transistors or sensor outputs, either a positive, negative, otherwise known as a sourcing output, or negative, positive, which is a sinking output. I'm going to keep it at PNP. And then for down here, for our switching element function for electric axes, you can either choose between naturally closed or naturally open contact. I'm going to choose naturally closed. And then below, no option for the switching element for the pneumatic axis, but it's an naturally open contact. Then from here, we're going to click continue to go to our next step. This then asks if we want any sort of additional tubes for our front unit. What this means, I'm going to hit that info button, but essentially it asks if we want any additional tubing for the pneumatic mini slide that we have here with certain ambient temperatures listed, the temperature dependent operating pressures these tubes add, colors, so on and so forth. I'm going to click without now, but we could add to a total extra of 4 tubes on this additional tube option. Next, then we have our cable outlets. So these are going to be the length of our cables from our gantry system to our control cabinet, which has all of our drives inside. So I'm going to leave these at 5 meters, even though we have a few set options, 2, 5, 7, and 10. And then the energy chain, the tube length as well for our in our energy chain for our pneumatic axis. So this can range from 1, 2, and 5. I'm just going to match it up and put it to 5. For our mounting then, we have 2 options for mounting. We have profile mounting, which is the standard mounting style of the Festo actuators, or an adjusting kit. I'm going to leave it at profile mounting, but I am going to open up our info tab just to kind of break down what it means between the two. So profile mounting, this is the standard way, connecting our x-axis to a bearing surface, but then our adjusting kit, it connects the x-axis to the bearing surface, but it has this adjusting mechanism to compensate for any unevenness in the bearing surface or to align axes parallel to one another. We also have options for wall mounting and bearing surface that are not listed in the options on our HGO configuration today, but you could see wall mounting like in a linear gantry system, for example, as an option. So we're going to leave it at our standard for profile mounting. And then skipping over mounting method, because I want to talk about it a little more in detail, just go to our printed user documentation, just choose English for that, or you have an option for German as well. But what's really cool about the handling guide online is you can actually get this full 3D gantry system in a complete assembly in the box, ready to go once you take it out. Or you can have this partially assembled, where you have all your axes made individually, but then you have to mount them yourself on site in person. I'm going to go full complete assembly here. There is a price difference between the two, of course, complete assembly usually being a little more expensive, but it's a nice option to have if you just want to have this ready to go out of the box. Just got to plug it in, commission, configure, and then start running your program. We're going to click continue now to our final step where it puts everything together. You can already see some of the options I'll talk about next, like in this right hand section here. And there we go. We have this system ID C4221027. Always save this number because we'll be able to go back into Festo to look this up and find our exact HGO solution that we have made up. We then have our 3D system here for our gantry. I can make this a little bigger, as can be seen here, and then break down some measurements and stuff, or full dimensions in the X, Y, and Z directions of each. I'm gonna exit out of that. And then from here, you can get technical documentation for each of your axes, 2D, 3D CAD models you can add to cart immediately, commissioning files, you name it. You can also show the request, add cart from here as well. So I'm gonna save this for now, but essentially that is our configuration. I'm gonna X out of this now. I'm gonna click close. We didn't save anything. Oh no, what are we gonna do? No worries, we're just gonna click Control V to look this up, taking that order ID that we made for before, and as we see here, what we just configured, we can search up on Festo's site. And this is nice because then here we can go back in and we can actually edit this as needed, showing all of our options below that we have chosen and all the parts in our bill of materials. And we're back. Thank you very much for coming on this step-by-step process of walking through just one showcase use of the handling guide online in a 3D gantry system, showing how we can mix and match both the electric servo or electric actuation portfolio and pneumatic portfolios of Festo's offering in motion control technologies, and showing how easy it is to bundle all of this information for a gantry system together in one place. I do hope you come for the next video. If you have any other questions, you can always reach out to your specialists like me and others here at EandM. Thank you again, and I hope you have a very great day.